Now let's, before moving to the second graph, let's quickly revise what we discussed for graph one. So this is the summary, displacement, comparison with the graph, and we came to the conclusion that graph A does represents motion in one dimension. Now moving on to the second graph, velocity displacement graph this time, a circular curve. So what does it represent? It represents a circular Vx graph, right? Which is centered at this point, origin, x is equal to 0 and v is equal to 0. Of course, the axes are velocity along y-axis and displacement along x-axis. And geometrically, a circle centered at the origin will be having the equation x squared plus v squared is equal to r squared, where r is the radius of the circle. Okay. Now, see this graph that I've, of course, this is AI, and this is incorrect with reference to the given question here because it is geometrically center is at the origin, not this one here. But anyway, that doesn't affect our uh, understanding about the graph here. For every x comma v point on the circle, the sum of displacement squared, the velocity squared is a constant, is what this means. Which means if you find a point here, find out the v value and the corresponding x value and square them and add them, that should give the same value as of a point here. For that matter, every point of the circle. Okay. Yes, we are trying. Like I said earlier, we're trying to make sense out of both maths and the physical part of it. First, maths part. So for every x comma v point, the sum of displacement squared and velocity squared is a constant, like we discussed. Now, a circular phase space diagram. When I say phase space, it is not velocity displacement here. We're talking about a separate concept altogether. A circular phase space diagram is the signature of uniform circular motion when projected into two variables. Yes, again, we are now discussing chapter number 2, which is motion in a straight line. Therefore, making sense out of this would be really difficult. But then just make it into your note that a circular phase space diagram is the signature of uniform circular motion when projected into two variables. Okay. Most importantly, a circular curve in x comma v space means the system has two independent variables which are changing together. And what would two independent variables changing together means? That the motion is not happening around in a one-dimensional plane. It is rather taking place in a two-dimensional place. Oh, sorry, two-dimensional space. Now, if this graph has to make sense in one dimension, or maybe if this is a graph which is trying to um, portray two different variables, this should represent a two-dimensional motion and not a one-dimensional motion. A circular curve in x comma space means the system has two independent variables which are changing simultaneously, right? In contrast to one-dimensional motion, where displacement is the only spatial variable, or for that matter, it can be velocity or acceleration, but only one variable changes with respect to time. Okay, not two of them changes. Now, they are not independent in the way required to produce a circle, the geometry of it. But there is a different question coming along with this. Can a one-dimensional motion produce a circle in a Vx space? Now, this is where I I slightly disagree with the question here. See, I'm not a physicist, and I'm I'm time and time again I would like to assert on the fact that I'm not a physicist. I'm not a teacher, a qualified teacher as well. What we are trying to do here is to make sense out of the given questions here. Having said that, when the question is itself is not so clear to us, or the question itself may have certain aspects of um, missing information or maybe inaccurate information, there might arise corresponding error in analyzing the question as well. To make it short, improper questioning would lead to improper answering, right? Incomplete questions cannot be made sense to find a proper solution. I'm not saying that this question is incomplete here. I'm just saying that since I didn't find the option to be, um, very straightforward, the explanation would actually make a bit of confusion. There are many textbooks which says that, or at least not many, I would say at least one or two textbooks which says that option B is incorrect. And JE Mains has published the key, the NTA has published the key which says as A, B, and D are the correct options here. So definitely we will have to go with what the NTA says, because finally they have the authority conducting the paper and they have the authority to, to say which option is correct and which is not. So I would say this option is, in my opinion, I would say it would have been better not to include this graph at all. Why? I'll just take you through that. See, a one dimensional motion can actually produce such a curve when we discuss about the topic simple harmonic motion. For instance, if we consider the simple harmonic motion of a spring mass system, where x of t is a cos omega t, given by the graphical representation here, cos 0 is 1, is 0. Yeah, so we have x of t is equal to a cos omega t. Differentiating this will give you v of t is equal to minus a omega sine omega t. Sorry, yeah, minus a omega sine omega t. So this is cos omega t. Differentiating this equation with respect to time will give you a omega sine omega t, right? If you want. And in fact, I suggest, very strongly suggest, please make a note of these graphs as well. Now we know that A is the amplitude and omega is the angular frequency that we discussed in the previous graph. If we square these two expressions, we get x square is equal to a square cos square omega t, and v square is equal to a square omega square. My bad, this is correction is omega square sine square omega t. Now, are these variables familiar, x square and v square? Exactly, that's what we have in the graphs here, which is the corresponding y-axis and the x-axis. Now, if we divide these by a square and divide x square by a square and v square by a square omega square and add them, what we get is, my bad, x square by a square plus v square by a square omega square is equal to 1. Is this equation familiar? Well, we just noted that this equation, the given in the circular graph, is actually x square plus v square is equal to 1, and not x square by a square plus v square by a square omega square is equal to 1. So there is a minor difference here. Well, what is that? What does it convey? What kind of equation is this? This is actually not the equation of a circle. This is in fact x squared by a squared plus y squared by b squared is equation of an ellipse and not of a circle. Okay. Now, why is it an equation of ellipse? Because we have the equation, the mathematical form is x squared by a squared plus y squared by b squared. So if we compare this to the equation of an SHM, we have x squared by a squared plus v squared by My bad. This is v square by a square omega square. And this here is a, and this much portion here is b, right? So what is this b equal to here? This b equal to a omega, and a here is equal to capital A, right? Yeah, so exactly the major axis and the minor axis. So A and B represents the major and the minor axis. We know that. So A is equal to amplitude, this portion here, and B is equal to A omega, the with the vertical axis here. Since omega is not okay, now see, I don't want you to make a note of this one, since omega is not equal to one in general. That actually doesn't make sense. My bad. Yes, it is an error. I stand corrected here. Please neglect this one. Okay. You might be wondering why is the ellipse vertical here? Because maximum displacement is a and velocity is a omega, which is this vertical region here. So velocity a omega is omega times displacement. This is displacement, maximum displacement, and it is omega times, which means it is increasing. It is multiplying by a factor of omega, and therefore the y-axis will be more than the x-axis. That is why the graph is stretched along the y-axis. Now, if the given question in the JEE mains was a graph which is vertically stretched, I think that would have made absolutely no objection. Now, see, now I've given you the logical proof for my thought here. But exactly, we can't. We are none to question the authority of NTA. Having said that, there is another thing that I would like to add here. Although SHM is not a circle naturally, because we know that x square plus b square is a constant, is a circle. Rather, in the case of SHM, we get a ellipse, which is vertically enlarged. Now, there is a way to make this into a circle. It's actually called a scaling of axis, wherein what you do is you divide the velocity term by omega square and then make it x square plus v square is equal to a, in the form of x square plus v square is equal to a square. Okay, let me just tell you that. This actually means, this equation actually means that the velocity values and displacement values do not have equal weights. Why? Because x squared by 1 and v squared by omega square. This is actually what causes the velocity to be stretched along the y-axis. Now, can we make the stretching uniform to both x and v so that we can convert this velocity displacement from an elliptical shape to a circular shape? Well, that's what we're trying to discuss here. It can actually be done. In fact, the graph which is stretching in one direction as an ellipse can be made into a circle by choosing a different set of axes, which is what we call as scaling of axes. So what we do is we introduce new variables instead of small x and small v here. We introduce new variables, which is along the x-axis as displacement by maximum displacement, and along the y-axis by velocity by a omega. So to put it into simple terms, we divide x by a and then plot a new x-axis. We divide v by a omega and use this as a new set of values to plot the y-axis. And what difference does it make? What it does is the equation of the simple harmonic motion, which was earlier an ellipse, now becomes x square plus y square is equal to 1, which is now the equation of a circle and not of a ellipse. Okay. And why is this mathematically valid? Because we are dividing the displacement axis by a and dividing the velocity axis by a omega. Both the axis now reaches the limit of plus or minus 1 along x and y axis, and they have equal lengths for the circle. Okay, so I have shared my opinion on this graph here. I've also told you why is it a bit confusing. Why is it not? I know it's kind of a gray question, a gray option, I would say. I've given you my opinion on that. Now, before we go to the next option, let us have a quick review of what we discussed so far. And if you have not written any notes so far, please make at least note of the summary here. Equal weightage, x and y, x and v, circular representation. Simple harmonic motion is one dimensional. There's only one spatial variable. So we have simple harmonic motion x t v t, adding these two equal to 1. This is an ellipse and not a circle. How can ellipse be made a circle? By choosing the concept of scaling. What is scaling? Dividing the axis, creating a new axis, then defining it, then drawing the graph, which gives us a circle. Therefore, x and y now become, the xy graph now becomes circular in nature, which matches our option. Okay. So, well, it's up to you to decide if this is correct or incorrect. Well, in my opinion, I would suggest that you go through the NTA website again and go to the official key again. See, because to err is human. I might also have gone through and I made a error in going through the key. Please go through the key. If you find it different from the answer that I've given, please reach out. I'll make the necessary amendments. Okay. Now, so yes, I would say this is NTA says this is correct for sure. I would partially agree with that. Okay. Now, having said this, there is another argument which might come to our mind regarding the vertical projectile motion. Now, those who are here after completing the second chapter, you might be wondering, isn't that a typical graph of a vertical projectile motion where velocity has both positive and negative values at the same displacement, right? I would like you to pause the solution here, go through that concept in detail, take a random value, say velocity is 30 meter per second, calculate displacement at every time interval, calculate the velocity as well, and plot a displacement time graph and a distance time graph and see, uh, check if it comes to, it gives you a circular graph. Now, if it gives you, it clearly indicates that this is a velocity displacement graph of a single dimensional motion, which is vertical projectile motion. Although it is going into the air, there is only one variable changing at a time, that is one dimensional motion. If it is not giving you a circular motion, then it clearly means that there is some problem with the correctness of this question. Okay. So the next part, we will discuss this in two halves. One, regarding the vertical projectile motion, and two, regarding the mathematical part of this equation again.